All right, so we are on solutions still. All right, so some words that I want you to know about solutions as well. If a solution is saturated, then that means that it's like taking sweet tea and putting so much sugar in it that the sugar it won't dissolve anymore. Okay, so a saturated solution is insoluble, meaning that it's not dissolving. A simple rule, like dissolves like, so polar substances will dissolve with other polar substances and non-polar. So like dissolves like. Fluids could be either liquids or gases. A gas is actually considered a fluid. Air is considered fluid. Miscible fluids can mix in any proportions without separating, like Chex Mix, salad. You could even do I won't go to something but you could say even like sweet tea or something. It does dissolve, but you can kind of extract out some of that. But immiscible are things that don't mix. So like vinegar and water. It's a good example of something that's like immiscible. Solvents and solids. So like dissolves like again. So oil, grease is not soluble in water. Salt is. Okay. Again, if you heat up water and you put some salt in it, they're going to dissolve and you're going to have basically salty tasting water. Is the salt still in the water? Yeah, that's why it's salty tasting. Okay, so it is mixed in there. So hydration, another term here, is an attraction of crystal surfaces versus water molecule. So hydration is when something is considered to have water. Okay, and there's an attraction of water. Soap provides both polar and non-polar environments. If you take water and you put soap in it, it could kind of separate out. It's kind of cool looking. In fact, if you're home and you're needing some kind of cool idea to do with kids or just for your own enjoyment, if you take some water and you put some pepper in it, kind of floats on top, and if you take a little drop of soap and you put on top of that pepper, everything will sort of separate out. It's kind of cool. All right, so concentration. Concentrated is meaning that it's pretty much a pretty big amount of solute versus solvent. I used to have a friend that made very concentrated sweet tea because everybody likes their tea different. This one kid told me once that McDonald's had the best sweet tea ever. And then I got a sweet tea from McDonald's. I thought I was going to die because it was all just basically sugar. I like sweet tea, but not that sweet. So I always get a half and half sweet tea when I go to McDonald's now. But my friend would have concentrated sweet tea and you could just add water to it to your own likeness. Okay, so that's concentrated. Large amounts of solute, large amounts of sugar there. And if you dilute it, that's what I was talking about before too, then it has a smaller amount, obviously. All right, so concentration of measurements. This is kind of where I'm wanting to get to, is basically figuring out percentages. And then I will see how much more, but this is my main goal. So concentration ratios. Sometimes whenever you're doing solutions in science, we refer to in like parts per million or parts per billion. And so that would be like if we had 98 parts of solvent. So basically 98 milliliters of water. And then 2 parts of solute. So two little sugar cubes or something versus the same amount. You have to have the same amount of those sugar cubes of water, only 98 of them. So you have total of 100 volumes or 100 dots or whatever you want to say, but it adds up to 100. Anyway, so those could be parts per 100 or parts per, in this, in science, we get a little bit bigger, parts per million or parts per billion. And then you can figure out the percent by volume and the percent by weight. And then the salinity is basically this whole concept right here that I'm talking about up here, only with salt. So if you take 2 little grains of salt, okay, or 2 grams of salt versus 1,000. Okay, so this is saying 1,000 grams of solution. All right, so molarity. This is where we would take moles of solute. Okay, we briefly talked about moles in the last chapter versus liters of solution. Okay, so moles of solute in 1 liter of solution. So if you ever get a 2-liter bottle of pop, just half of that is a liter. And a mole is, so let's say we were talking about, iron. I believe the mass of iron is like 55-ish, 56-ish. So a mole of iron would be about 56 grams. Okay, so remember, whatever that little number is on the bottom, the mass number, that a mole of that is how many grams it would be. So if we were to actually weigh it as a mole, it would weigh 56-ish grams, which isn't a lot. But anyway, that would be 56 grams per 1 liter, okay, of solution. All right, so we've got some saturation and solubility charts here. So not really going to spend a lot of time on this. Just, we've already kind of talked about these terms, and that's really what I'm mostly going to ask you is just, saturation means that it's got a lot of solute in it. Okay, it's sort of like saying that it's concentrated. If it's saturated, though, it means that it's basically over the limit. Solubility is the concentration of saturated solutions. So basically how strong it is. And it's going to obviously depend on temperature. Like, for instance, if I was going to make sweet tea and I had a glass of cold tea, could I make sweet tea? Yeah, you can put sugar in it. It's all going to go to the bottom and you can, stir it around and it's still going to be sweet tea, but it's not going to be like, all dissolved through. Okay, some more properties of water. Water has electrolytes, which is pretty cool. Like, if you go running and stuff, if you play sports, then a lot of times they'll have Gatorade because Gatorade has a lot of electrolytes in it. You can cause water to have electrolytes by adding like solutions, like salts and stuff to it. And electrolytes can actually conduct electricity. So, you can stick this cool apparatus in and it can actually create a light because of those electrolytes that are in there, which electrolytes are just ions. We've talked about ions. It's where it's taking those different chemicals and it's sort of separating them into positive and negative charges. And whenever you do that, since you've got positive and negative charges, you can create electricity with it. Non-electrolytes are non-conductors. That's like sugar and alcohol solutions. So ionization is forming ions from molecules. So, different things that can dissolve in water, like salts. Okay, and different properties of water. So ionization is whenever you take in water and say like hydrochloric acid, and whenever you take this hydrogen and you add it over here to the water, then you've created what is called this hydronium ion, which is positively charged, and then this chlorine ion, which is negatively charged. And like I said, you don't really have to know like how to do this or anything like that. You just need to know that when it separates into a positive and negative charge, then it's known as ionization. Boiling point, we've already talked a little bit about boiling point in the past. Normal boiling point is around 212 degrees Fahrenheit or 100 degrees Celsius. This is where the temperature, this is the definition here. This chapter is a lot of definitions, so some of you will probably like that. Temperature where the vapor pressure is equal to the average sea level of atmospheric pressure. So anyway, what starts to happen is those molecules start to boil, obviously, and then parts of the surface will begin to evaporate. And that's this vaporization term here. This is where if you go in, and this is caused by pressure. You've probably heard of this maybe before, but if you go into water and it's there's a lot of pressure, the farther down you go, and it can cause there to be gas inside your blood. This nitrogen gas can be inside your blood, and it can cause severe pain. So, you have to really sort of train and stuff before you do too much scuba diving. But it is all caused from, things that aren't, the solutions inside your body aren't acting the way that they should. Okay, I'm going to stop the video because I feel like I've